I'm building a version of Tubalcain's spool valve engine, which requires an eccentric that he indicated, I believe, that was not simple to build. I figured out a way to build this thing, and I like his design of the engine so much that I'm going to set up to build multiple versions of this, varying probably in length and throw. So this video is just going to be about building this eccentric follower link. To do it, you need a rotary table. Now, it doesn't have to be a 10-inch rotary table like that. It could be something smaller, like this 4-inch table. Grizzly. That would work. You can get these for $100 or so. But you need a rotary table. And you need something. I'm going to use this piece of aluminum as a fixture. We'll get to all that. The first thing to do is lay out the eccentric follower link on a piece of stock. I chose brass because I had some. Could be anything. Probably needs to be thin. You can see the scribe lines for this follower link, which is 0.875 here, and it's with a half-inch circle, half-inch diameter area for the eccentric, and then it's an indeterminate length here. Make it too long because you'll cut it later. Fit. Notice the bolt holes, or notice the holes. 1, 2, 3, 4, 5, 6, 7. You need these to bolt the eventual piece down to its fixture. Now this is not going to be the piece. This is the template for the piece. I'll keep this. This is what will allow me or you to create eccentric follower links along using this design in the future. What I'll do is lay it out. I'll clamp these two together, and then I will mark the relevant holes. The scribe lines really don't make any difference. I'll mark the relevant holes in this piece of stock or one like it, and then I'll use this as the eventual workpiece. I'll do the milling on this. Now there's several ways this could actually be done. This is just the way I've chosen to do it. I'm going to clamp this template onto this piece of aluminum stock. It's going to be a fixture. It's 1 7/8 by 1/4 inch by I don't know how long. I want to get them square. I want to get the brass square with it, so that's why it's up against the ledge of my curt. I want to clamp it on there, and now I'll move it over to the now what I'll do is I'll mark these holes. I'll mark all of these holes in the aluminum stock, and then I'll drill and tap them 440. I'm going to drill through holes because that makes it easier, but they don't have to be. I don't know why you wouldn't though. And I'll tap them 440. All right, I use this template to lay the bolt pattern out on the fixture. I drilled and tapped the holes for 440, with the exception of this hole, which doesn't need a screw. It's used later on the rotary table to line it back up without having to center the rotary table onto the spindle. So you may have wondered, well, why do you need the fixture? Why do you need the template? You scribe the workpiece in the template and then drill the holes for the bolt pattern, just to lay the holes out on the fixture. Well, the answer is you don't. You don't need it. You could easily just scribe the workpiece out on the fixture, center punch the holes and drill them. You don't need to go through this step, but I did. It's not necessary. Now that the holes are drilled, I could use transfer screws in the holes to create the hole pattern on this piece of brass. Or I could clamp that piece of brass on there, flip it over, and use a center punch through here if I had one small enough. And it would be worth investing in one small enough probably to do that. I think I've got one. That's all irrelevant at this point. The next operation is to do exactly that. Bolt this piece down to the fixture and prepare for milling. Well, as it turns out, I did not have a transfer punch small enough to fit through these 440 screw holes, and using transfer screws would be way too tedious. So what I'm going to use is this number 43 drill bit that I used to drill the screws holes to be tapped. There, I finally got that out. So just kind of line it up and peck it a little bit, and the aluminum is marked. The brass is marked, and I will take a center punch on my auto center punch and make those punch marks a little deeper. And get a brace under that. Let's see what we've got. Yep, I can see where to auto center punch them. You probably can't, but I can. Center punching. dropping the center punch. Part of the procedure. Don't be alarmed. Now those are, I can find those with a center, not a center finder, but a center drill, number 0, I believe. I'm going to drill the clearance holes in the workpiece. I might fumble around a little bit looking for them. Always center drill them first so this drill bit doesn't walk. I'll drill one for you, then come back when they're all drilled. Lining these drill bits, small drill bits in a chuck can sometimes be a chore. The location of these holes doesn't have to be precise as long as they will allow the heads of the socket head cap screws to clear the end mill when I'm cutting, when you're cutting the piece out. Well, I'll be back. You wouldn't think you could break the tip of a high-speed steel center drill in a piece of brass, but you can. There we go, it's all deburred and drilled and deburred. It's ready to bolt to the fixture and mill. Before we do that, we have to align the rotary table with the spindle. I'll show you how I do that. If you have a rotary table, you need one of these. It's a coaxial indicator. And then make aligning a rotary table with the spindle, a piece of cake. You just insert this baby into a collet, 3/8 inch collet. Choose the proper feeler. I know from experience that's the right one. I'll lower the table a bit for everything to fit right. Let's see if that's enough. Bring it up a notch. Actually, I'm still not low enough because I'll bring the spindle down to meet the rotary table. Okay, so you get it set up like that and kind of align it by hand. You see how it's way off in the X dimension. I need to move. Oops. Oh, it doesn't look like I've tightened that baby up. Of course, I always forget to remove the protection ring here. Alright, now I'll show you. See how it's off in the X dimension? So I'll kind of guess. Get a little closer here so you will be able to see better. Not too far. Knocked a bunch of crap off the vise. Let's see. Get back. How about Y? There we are. Let's see. You probably can't tell from perspective, but it looks like we're pretty close now. You just have to get these pretty close. I'm going to indicate off of this machined ring. First, of course, I've got to slow the mill down, and I'll change the step pulleys off camera. All right, I've got the mill slowed down. I'll put the arm in the coax and let it rest against the indicator post. Come down here. Alrighty. Now, the objective of this exercise is to make that needle quit moving. Just turn one of the axes. I chose the X. Of course, I always choose the wrong direction. Now I'm doing the Y. I'm getting some results there. There we go. Turn it until it starts going on the X again. Now I'm on the Y. A little too much on the Y. Back it off. There's some X action. Too much. Back it off. Okay, that's reading each division is 5/10,000. Let's zoom in a bit. Is that focused? I would say we're right on the money. The workpiece is securely bolted to its fixture at 6 points. It's necessary to really hold this thin piece of material down when milling. If you don't, if you're milling a length that's not clamped securely, then it will lift the material, and that's never good. I broke 2 end mills doing that on the original piece. And you might say, well, how am I going to, we know the rotary table is centered with the spindle. We did that, but how am I going to center the workpiece on the rotary table and thus the spindle? Easy. I've got a pointer in the mounted in a collet. I'm just going to come down here like this. Looks like I've got some burrs or something. Anyway, I'll come down there like that. It's centered, and I will clamp it in place at that point, and then we'll begin milling operations. I forgot to mention that while it's not necessary to lay out the circular components of the eccentric follower link, you do need to scribe in some lines for the link part. If you can see them there, I kind of etched them in with my carbide scriber. Now it's time to bolt everything down and get everything set up. Everything's clamped down, screwed down, bolted down, and we're almost ready to start milling. I'm going to mill the inner diameter for the eccentric first. I'll show it to you here on Toley's excellent drawings. Right here. I'm going to mill that inner diameter first, which is a ½ inch diameter, and then I'll mill the outer diameter. It's set up so that that center hole we talked about earlier is aligned with the spindle axis. So since the diameter of the hole I want to mill, the hole I want to create, is ½ inch, we need to offset the table ¼ inch, but not really, because we have to account for the width of this end mill, or more specifically the radius. This is 1/8 inch end mill, so the radius is 0.0625. So what we need to do is offset the table 0.250 minus 0.0625, which ought to be 0.1875. So I'm going to offset the table in the X direction, although it makes no difference. 187.5 thousandths. There's 185, 186, 187, 187.5. I'm going to call that good. If it's a little bit over, a little bit under, then I will return the eccentric, which I've already made, but I'll recreate it to match that hole. When I was watching Tubalcain's videos, and he mentioned that the eccentric follower link was somewhat difficult to make, I was thinking, well, we ought to make that first, and then turn the eccentric to fit. So that's what we'll do. I'll come down here, set the DRO, then drill down with that 1/8 inch end mill, 65 thousandths, and then I'll be at the level of the aluminum, and then we'll start turning the rotary table and mill out that center part. There we go. Now it's time to cut the outer diameter, which is not a full circle, and it needs to be 3/16 of an inch wide. The total outer diameter is 0.875 inches. 0.875 minus 0.5 is 0.375. Well, then divide that by 2 to get the actual width of the workpiece, and it's 0.1875. But where do you start and where do you end? Because we don't want to cut the long piece off, the link off. So what I do is, since I've got a scribe line on there, I come down and that's exactly where I want it on this side, and I'm set my pointer there and it happens to be 277. So now I will do this and get over to the other side. Oh, by the way, that end mill I used wasn't the sharpest cutter in the block, or sharpest cutter in the drawer. So it was a 2-flute Putnam that I kind of inherited. And so I swapped it out for a 4-flute, it might be a Putnam, it's a good one. We'll just hope it's sharp. I don't have any new ones that are sharp. Well, I don't have any 1/8 inch new ones at all. So this dimension is really not hypercritical, but it'd be nice if that link, the rod you might call it, was about a quarter of an inch wide. I'm easing up on it. I think that'll do her. And we're at 232.5. So I'll write that down. And I'll turn between 277 and 232.5. Found an end mill that makes me happy. And there we are. The circular parts of the eccentric follower link are almost done. I should have cut a couple thousandths deeper. You can see the foil I left right there. I'll clean that up later. When I cut the straight portion of the link, I'll cut a little bit deeper. The long axis of the eccentric follower link is now aligned with the x-axis of the mills table, and I'm ready to begin the cuts of the long piece of the link. I'll cut a little bit deeper because I left a piece of, it didn't go quite deep enough. There's a foil thin piece of brass left there, and I'm not exactly sure if this link is actually going to be usable. What I wanted to show, however, was not. I wanted to show how to build the link rather than more than anything else, because I've already got a good one. The reason I've got my doubts about its usability is because I used a bad end mill to cut that 1/2 inch diameter, but we'll see. Looks pretty good. I cut deep enough that time. So now we'll cut the other side. Well, here we are. I've got 2 eccentric follower links that I could use on engines of the design I'm working on, Tubalcain's design. I like the original one a little bit better because I used a sharper end mill. This one is eminently serviceable though, the one I just built using this fixture. And the fixture's the thing. If you'll scribe the one time, if you'll scribe the shape of the eccentric follower link into your fixture, then you can skip this step. The only thing you'll have to do when you put a piece of material on the fixture is scribe the lines in for the long part of the link so that you can cut them out with the end mill. That's all there is to it as far as building the eccentric follower link on the rotary table. And I think you wind up with a good product. I don't have a vertical bandsaw. I've got a couple horizontals. So, well, actually I do have a vertical bandsaw, but it ought to be in the scrap pile. It certainly won't cut a straight line. Maybe I can work on it. I believe Tubalcain used a vertical bandsaw in the creation of his links, and that might make it easier. But this was pretty easy. Once you get this built, then you're home free. I'll save this. It doesn't look like much, but it's the key.